thank you guys all very, very much for being here. This is number 37, so we are 3 years and 1 month into Analyze Boulder. Thank you. None of this happens without the leadership team, and the leadership team includes me. I'm Tony. Justin with the camera, he's running around with the curly hair. Joe, Diana, Jennifer, and Jordan. Where did Jordan go? Oh, she's doing tech in the corner. This also would never, ever happen without Galvanize. They give us the space, they open this up for us, they make everything happen. I just want to say thank you to Galvanize. They do have a data science track if you guys are interested in looking into that, and a mailing list, so go ahead and sign up. Thank you, Galvanize. And you guys, month after month after month, we pack this place, and I just want to say thank you very, very much to you. Give yourself a round of applause. So we meet about once a month, but we also stay connected in other ways. We have a Slack channel at analyzeboulder.slack.com. You can email me, and I will give you an invite. We're also on LinkedIn. We share a lot of jobs that way. I know plenty of people here who have gotten jobs directly through Analyze Boulder here. So if you're looking for a job, do announce and all that stuff, do that job available. And Twitter. So we ask tonight, take some pictures, make some comments, make some jokes, whatever. Send it to @AnalyzeBoulder. All right. So, like I said, 3 years and 1 month. We had a really generous grant from Denver. City of Denver? Community Startup. And we drink so much beer that we've exhausted our resources. And so what we're going to do, instead of going to anything corporate, we are going to try to raise some funds from you guys. So you will be getting an email about this. Just wanted to give you a heads up. We've already got $130 towards our goal. This will cover us for another year. Anyway, love you guys. Thank you. One of my favorite parts of Analyze Boulder is the announcements part. So jobs. Who's got jobs? Who's looking for them? What's up? Give me some announcements. We're going to have a mic go around. Don't be shy. I know you guys are not shy. Got one.
I'm Josh. I work currently. We are looking for a MySQL DBA, sort of split between MySQL and eventually sort of pick up some Hadoop. Started doing it, we'll deploy it, so it'll be sort of split between the two. So that sounds up your alley, let me know.
I saw another one a couple of stores down.
Hey, I'm Jacob with DMI.io. We're a marketplace for business data, need a full stack developer to connect the tech stack that's driving the marketplace. We just started Boomtown, so we're still not quite at the ability to pay a person yet, but that's on its way.
Don't you have lots of stock options?
I'm not going to insult you with that one.
Any other jobs? It's summer. Now's the time to switch jobs. One more. Give me one more job. Whose company is hiring? There we go.
Full stack web dev. I work for Handshake. We do sort of a job market for college grads. We've got a lot of data that nobody really analyzes. But we've got reports, like not real machine learning or anything. But yeah, we're Ruby on Rails. Looking for anyone who's like full stack or friend.
Awesome. Next, let's talk about events. I know there's a hackathon coming up. I think it's coming up over at Avery. APIs. IPAs and APIs. I know that one's $40. Who's got other events? Richard's always got some cool stuff going on.
As a spin-off of Analyze Boulder, the Data Detectives has been on Wednesdays at BJ's, 11:30. We are a LinkedIn group, so if you go to LinkedIn, just search on Data Detectives Boulder. And we're kind of more focused on the MOOCs and studying various online courses and the like. 2 weeks from today, edX is starting a Spark series, and it will last pretty much the rest of the year. It's a It's June 15th, and we're going to have some study groups on that. So if you'd like to join us, do so. Also, I'm looking for some mentors. We have a lot of people who get into Texas looking for jobs and the like, and helping them get up to speed as a data scientist. Appreciate it. So if you would like to have a free lunch with data detectives on 50 days, come see me and just chat about what you're doing and about how you got hired, and how your company is hiring in the area of data science.
Thanks, Richard. Another conference, Jake. Jake from State Farm.
Not quite a conference, but I mentioned what I'm working with the team to do, and actually there's one of the other teams here tonight. Similar thing. Amanda and Keith from Everett. We have a bunch of customer interviews, and both of these groups are looking to do data science. In our case, it's people who are using third-party data for various purposes, whether you're paying for it or you're getting it for free. Understanding how users of data think about that would be really helpful us. For Everett, totally. I'm going to do this for you because you should. Frozen for data science. You should. Love you.
Any chance you're looking for a user experience researcher? I'm happy to volunteer my time, given that I've got some right now.
Yeah, so for me, it's Jacob at tmi.io.
Awesome.
Help us out, that'd be awesome.
Post it. Awesome. Post it to Slack, post it to me. Awesome, we've got, cool.
So next week, on my start week, there are lots of things going on. There's 5 channels, and counting some of the people who analyze data, really helpful. Definitely check out on my start week.
Awesome, I had no idea that Longmont also had a startup week. Got a question over here. How many people here have been to a demo day for Boomtown? Oh, wow. Demo day for Boomtown is awesome. It's really, really great. And then, anyway, Diana.
Hi, this announcement is for the ladies. My friend Sarah and I are starting a new meetup group for women in data. So if you're a lady or identify as not a man, you can come to our first meeting, which is next Wednesday here, and look for the Women's Data Meetup group on meetup.com.
Awesome. All right, you got 2 seconds to volunteer for one more announcement. Anybody? All right, we have a really awesome lineup today, so I want to get started. So we are going to start off with Adam Evans, who's going to be talking about mountainproject.com. It's a climbing recommendation engine. After that, we're going to Michael Lewis, and he's going to be talking about predicting what's in your food and your meal. And he did it with pictures, so I'm really excited about that. And then Tom. Now, Tom told me not to worry about pronouncing his last name, but that it's really, really similar to Orville Redenbacher. So Tom is awesome. Tom. He's going to be talking about the context is critical in predictive models. After that, we are going to kill the K. So, without further ado, Adam, are you ready?
Yes.
Adam, yes. Thanks, Adam.
Okay, quick show of hands. Who here has been rock climbing outside in the last year? Okay, yeah. Wow, lots of people. Cool, so this is mountainproject.com, the destination for technical information on rock climbing. You see, you have the route name, how highly it's rated, how hard it is, what kind it is, how tall it is. You get this great text description down here. This is the third Flatiron. It's being described as possibly the best beginner climb in the solar system. So we're very lucky here in Boulder. And this might inspire you to actually do the climb. And I was also attracted to this hierarchy. So it's organized geographically, and it makes this kind of beautiful tree. So the root of the tree, I think, is the whole country, and then the different states and regions and areas down to the specific wall, and then the leaves of this tree are the actual climbing routes. And it turns out there's this really elegant algorithm to navigate this tree called tree traversal. It's a recursive algorithm. And so I wrote a little scraper to visit every one of these pages and grab all these cool little morsels of information and build a database. But one of the first challenges. Sport and trad climbing use the Yosemite decimal systems, the Boulder system. You can see there's some examples here. But Boulder uses a different system. So not only do these have little appendages and letters in them, but they're not even in one column. So what I did here was I parsed out the number in each of the grading systems, and I used an empirical cumulative density function to kind of turn these into a percentile, and then was able to merge them together that way. So this distribution is between 0 and 1, and is a lot more uniform. Vocabulary. This was both the best and the worst part of this project. I used a document frequency range to come up with a list of about 3,500 kind of interesting words, and then cut more than 500 words from that. Stuff I covered, like people's names, locations, anything having to do with climbing equipment, and I really tried to isolate words that describe the style of you can see that stuff here. I love that I got the word bad. So you have this. This is the first version of the recommendation system. You find an ID on Mountain Project, put it in, and it gives you the most similar climbs. But no sooner do I push this to Heroku, but it says, nope, can't use Psyche, can't use SKLearn. And I was relying on these to do the parsing of the text description. So this is a big problem. This was me, very, very simple. But first, an aside, we're going to do some data viz. Harder climbs are generally rated higher. So on the horizontal axis, that's how difficult the climb is. The vertical axis is how highly it's rated. And you can see that there's lots of blue dots in the top left. And that's saying that there's lots of great, easy trad climbs. And then the converse, in the bottom right, there's lots of bad, hard sport routes. I really wanted to run TSNE on this data, so this is an unsupervised algorithm. It only knows words in the text description. And with that, it was actually able to separate out trad and sport climbs pretty well. So remember, we're here, that. And I thought about this more, and it's not a great user experience, right? You have to go to Mountain Project, get the idea, put it in here. And really, I realized this wasn't a recommendation system. This should be a search engine. And so I reworked TF, IDF matrix, indexed the climbs, played around with Bootstrap a little bit, and I made this. I'm not sure if I can click it, but we're going to try. And you can put in all sorts of descriptors here. But what I love is if you just hit enter, you might recognize that from your desktop background, the first climb. You can specify a grade too. So just some thanks here, Dean Wyatt, to Stephen Rouse and Adam Newman for our little study group, and thank you guys. And Mountain Project. We have someone here from Mountain Project. I feel honored, and I would love to take your questions. Woo! Okay, start with him first. You look like a climber.
Yeah, so you didn't who can help lead?
Who can help lead? What?
Lead.
Oh, that's great. Lead my climb.
Yeah. Oh, well, so you can filter by different types. You can say, oh, I only want trad climbs, or I only want sport climbs, or only bouldering. So you can filter it down that way. Yeah.
Have you contacted the Mountain Project? Trying to get this incorporated out to their site?
So a little bit. They're working on a full redesign of the site. Apparently, all goes back to like 1999 or something.
Because this is even past, I usually pull down, the chunk of their site. on my iPad.
Yeah, well, we can talk to Rachel about that.
How many results do you get when you search for rad?
Yeah, so it's limited to top 20. But you will get the most rad top 20.
I'd like to hear about an experience where you searched a favorite route and it recommended something else and what happened. The next route that you climbed.
So yeah, I mean, so one that in a lot of testing, I tested a lot with just Colorado data, and the one that came up was in Clear Creek Canyon called Guppy. I haven't actually found it yet, but that's the next. But there've been all sorts of. I think the biggest like kind of wonderful surprise was just seeing the nose come up as that first climb when you don't search anything because it's 4.0 and it has hundreds of votes.
It wasn't the Mike Banks program?
No, yes, that's right. So, yes, it was not. It was not that. It was. But yeah, it's been a really fun tool for discovery for my friends.
Two more questions, stop. Down to one more question, last question.
All right, I also wanted to show this. These are the best and worst words. I ran a ridge regression on just the star average versus all the different words in the description. So in the blue, those are the best words, and the red, those are the worst words. I love this one.
Awesome, thank you. Oh, I'm sorry. I messed it up. No. Sorry, Tom. All right, so poor Tom, I'm just scared to get that. Next up, we have Michael Lewis. Yes.
Hi, everyone.
Right there. I haven't started your time yet. It's okay.
I'm here to tell you about a project I worked on that I like to call ChefNet. So, there we go. So my goal of this project was to see if I could take pictures of food and make predictions on what actual ingredients are in that dish. So to do that, I used this technology stack. I relied on Python heavily, Visual Studio, MongoDB for streaming storage, pandas for everything, modeling. I used Keras, which is a great neural net package, and everything was done on an EC2 instance on Amazon Web Services with a big GPU. So I scraped 17,000 recipes from a website called allrecipes.com, which had 230 users submit images for those recipes. I then vectorized the ingredient labels from that data and vectorized the images in two different ways for two different deep learning models. But first, with the ingredient labels, as you picked out, salt is in everything we eat. Revelation. So, I mean, this was just kind of to see what my data looked like. For the images, I did a simple vectorization for plain convolutional neural net, and I also played around with some transfer learning. So, for that, I passed my images into VGGNet, which is a 2014 ImageNet winner, and cut it off at the last convolutional layer and took that 512 by 3 by 3 representation of the image as an input into a dense neural net, which, spoiler alert, actually did a little bit better than a pure convolutional net. So at the top here, ChefNet is what I call the transfer learning net. It did the best, 48% recall, 38% precision. Without VGGNet, which was just a 6-layer convolutional net, it did slightly worse. And you could compare that to like a naive guessing approach, which, since this was a multi-label problem, it actually came up with 6% recall and 21% precision, just for full disclosure. That's kind of the baseline. Some things it was really good at guessing from a recall perspective. So turns out if you train something learn salts in everything. It's really good at guessing that salts in everything. It's also really good with pastry, I found, so butter, sugar, egg, it's quite well with. From a precision perspective, these are ingredients where if the ingredient was in the dish, or if it guessed the ingredient was in the dish, it got rosemary and jalapeno and shrimp right almost 100% of the time. So, kind of an interesting little thing. It's not going to accidentally guess shrimp in your cake. So, speaking of cake, I invite you to use your own, sir. So, I don't know, I thought this was a chocolate cake when I looked at that image. Chef Matt also thought it was a chocolate cake. In this instance, it was wrong, as was I. This is a carrot cake, a very tricky carrot cake. But you can see here, it actually is doing quite well anecdotally with this cake in getting all the underlying components of cake. And then, whoops, one more. Oops, there we go. This is my, well, I guess this was a go-to lunch I used to get at Natural Grocers all the time, so I wanted to see what I thought was in that. And what's interesting here is, you know, I didn't train it to learn what mango or jicama was, so that was a lost cause, but given more data, it would be able to actually pick out those ingredients. So overall, deep learning is really cool, and it can get some surprisingly good outcomes with pretty simple models. So I'll leave you with any questions.
Thank you.
Yeah, if you were going to improve it, your predictions, what would you take as the next step? I'm curious.
I mean, I certainly would try to train with more data. 230,000 images sounds like a lot of images, but it's only 17,000 unique recipes. So if I had more variation in recipes, I could teach it what more ingredients look like. I didn't even mention, I only trained 159 ingredients because those were the 159 ingredients I identify and enough images to train it. So more data is always the answer. Just myself and maybe some people around me, but yeah, anecdotally it did as well as me generally.
So people on the
You would be shocked, actually. All right, I actually have, these were two all recipes. The one on the left just shows why this is a hard problem. Sugar cookies can look like virtually anything. And the one on the right is the same exact recipe because somebody was a jerk and uploaded their chili to the sugar cookie recipe. So, yeah, I mean, oh yeah, that last image, the salad was a picture I took with my cell phone. So actually, I didn't mention on my GitHub, install this and try that for yourself. Yeah.
So how do you think you train it to distinguish
Yeah, I mean, so this is, yeah, the Boulder was, honestly, I think they probably do look a little bit different in a way that maybe we can't even tell, but if that is true, then you could definitely train it with a bunch of gluten-free versus non-gluten-free cupcakes, and it would probably be able to predict decently well with some sort of confidence interval of what it thought it was.
Two more questions.
What does rosemary look like?
That's a good question. And that's the thing. It's not necessarily looking to find rosemary in the picture. It's just looking for what dish looks like it would have rosemary in it, right? Because it can't see salt either, and it always gets that.
Do you think you can improve it if you gave ingredients themselves?
I think I can prove. I'm not sure. So if I just fed it a bunch of pictures of rosemary and thought that that's what rosemary looks like, I don't know if a picture of rosemary translates to how it looks.
Well, I mean, all the ingredients just by themselves, if you take whatever it is.
Yeah. But I think the issue with that would be usually when the ingredients in a dish, it's not seen in that image. It's got to learn what flour looks like with in the incorporation with everything else. So it's an interesting idea though. Like, yeah. I mean, with a salad or something where you do always see the underlying ingredients, it would probably be better to if it knew what that looked like individually. But I think it's a different way of learning.
Awesome. Thank you, Michael. And if you guys are interested, there is a coffee liquid in the bag that you can get from Michael if you want to.
Okay.
All right. Up next, we have Reichenbacher?
Sure.
Sure? It's better than Redenbacher, right?
Well, I'm in deep trouble. I have no pictures of beer, mountains, or food. But so that's me. Here's my contact information. What I do is I develop customer relationship life cycle programs for primarily very large companies. And I've done this for quite a while. And just in the last years, I've come about something that is reoccurring with different clients. And the thing is not working. So there. And that is the oxymoron that I'm observing is that strong models create weak businesses, right? And the basic confusion that I see is that strong analytical performance equals strong business performance. They're not distinguishing between significance and relevance. And the lack of distinction between point solution and an analytical architecture, right, is different than predicting what a food looks like. A business is complex, and how do these different pieces fit together? So I want to run you through a case study of a client from about 2 years ago. We're going to go very quickly. We had 6 models, 5 predictive. One of the models was an in-market model. Who's going to purchase the next product? The other one, who is going to purchase the next product? The other ones were product specific. Who's going to buy product A, B, C, D? Now the application was very simple. It was a rank ordering of names in 10 deciles based on model score. So that's kind of the traditional application that is done in business. This is a dictionary. Again, there is no big revelation here. All models were applied all data points, and the belief the more data you have, the better it is. And it was always modeled against the complete database. So when you look at I don't want to spend any time here, a lot of transaction data. When somebody hands me something like this, at points where I would start asking questions, and that it is highly unusual to find interest and geographic data in a model that is primarily driven by transactions. It's an awesome model. I know the guy who built it, right? You can see the average response rate is 0.56. The model is 2% in the top decile. We identify 37% of responders and buyers in the top rank. This is really good work, right? So then the question is, what is wrong with that? Well, when you look at the structure of this type of model, right, because of the way it is set up under the belief that the more data, the better the model, the stronger the model, not the better, we are hitting always the same people. Right, decile 1 will have 96% of repeat buyers, decile 2, 81%. We are basically preaching to the choir. We are building models targeting those who most likely will purchase anything, right? So the other problem is the overlap, right? We have a portfolio of models, And the belief often is, well, we have different models, they should be hitting different targets, but that's just not the case. Because of the way the dynamics of the data flows through the model, you will find easily 60 to 80% of the time you're targeting the same people. And that brings us to neglect, right? So you're targeting these people out of 10 million in this case, 2 to 3 million were continuously contacted, but you neglected 7 to 8 million, and that is a huge problem, and we talk about that in a minute. So the consequences is that we have really strong statistical models that result in poor business results. Over-contacting leads to high attrition, little or no incremental value, neglect of long-term profitability because your single purchases fall in the bottom ranks. The solution is really not to throw all the data at the models, but segment them into specific pieces, right? For instance, your seedlings will have much sparser transaction data. They deserve their own model. They will have totally different data scoring to the models in there. The recommendation align data on models with critical customer functions. Don't confuse analytical strengths with business performance. Analyze the consequences of each model in the context of all other models. Don't look at them as point solution. Analyze what the analysis does, right? The indicator of strength doesn't tell you what does it to the customer base, and develop an objective evaluation, which is really a stratified control. Deflated model lift, but improved business performance will come out.
So you make an assertion about using models tailored to each segment that you'd like to address. Have you tested that assertion by taking a point solution and comparing the results of that point solution to your multi-model? What are the results?
Okay.
Oh, he has a mic.
Okay.
Well, thank you.
Okay. Oh, totally. That's the basic structure, and we have controls. Whenever we do it, we have a control in place. And especially when you look at the models and the data that scores in once you segment it, you will see that completely different data will score in, for instance, for the seedlings, right? You only have potentially one transaction, right? So, which means demographic, lifestyle data, all of that is going to be able to flow in. If you build a model against the diamonds and the crown jewels, and you combine them with the seedlings, then that data will never have a chance to be come in. Yes, we have done. And the models deflate, right? The models will show up to 50. They will show an index up to 50% less than what that model shows that I showed. Yeah, absolutely.
Do you think that this type of stratification is applicable to other commerce?
Oh, when you look at the dynamics of data and the context you put it in, I think it's absolutely critical to approach that in just about any analysis, right? Crop analysis, we talked about that before, where if you let data that is not relevant to the context come in, you lose, how can I say that? you lose the relevance, right? And you lose the significance that is specific to that one segment that you're analyzing, right, or that you're predicting.
What sort of data would you add to improve the quality of your model?
I'm sorry?
What sort of data would you add to improve the quality of your model? The next round?
What data I would add? Well, again, it depends where I am, right? I mean, I hope I understand your question correctly. I mean, for instance, with the seedlings, I have very few transaction data. What I like to use in there is demographic data, lifestyle data, data of activities that happen on the website, right? It's a very dry territory because you don't know anything about these people, right? This area here is much richer, and the moment you build a model just within the rich territory, and you take out the poor territory of the single owners, it automatically will deflate all your significance indicators. Your R square goes down, your accuracy goes down, but you're actually driving business, right?
One more question.
I'm just wondering if you are finding these different models, time series animation, something like that, when you see where it's like an evolutionary model.
Yeah.
Segments are evolving
Right.
over time.
Yeah.
So you get away from the how long trees wire identifying.
Well, you're getting at the heart of it, right, which is really the life cycle. There's a reason why it's called that way, right? When you look at the evolution, it goes from prospecting, it's a little bit, then it goes to seedlings, diamonds, then you lapse, right? And then you don't throw all the lapse people together and build one model against them, because your loyal previous customers have a different dynamic than those who were not loyal, right? And if you throw them together again, you will come up with a really strong model, but it's really an artificial intelligence, right? And so no, that's the whole idea behind it. It's like a circle. That would be nice to put on there, but it's a life cycle circle, and each model has a different purpose. Yeah. Yeah, exactly.
Thank you, Tom. All right, at this point, I want everybody to pull out their cell phone and bring up get your gallery open. If you have a whole bunch of food, take it to Michael. If you have a whole bunch of client pictures, take it to Adam. And if you have customers you want to talk to, go talk to Tom. Go talk to Tom. In the meantime, thank you guys so much for being here. Let's fill this head.